Hey, you good girl? Good day, welcome to Great White Retro. I'm Gord Fessick, this is Gigi, and we've got a small zoo here with Toes, Tai, and Star hiding around. Our topic today is a special package from Ultronics in Western Australia. We've got some Maximite kits that we're going to try to put together and get going. Let's get her done. This video was sponsored by Zerko Enterprises, home of PrintPlusWeb.com, your local print shop for the northeastern Wisconsin area. Zerko hosts auctions and flea markets in the tri-state area. Print Plus Web will do local print jobs for you of pretty much any size, including beauty posters, business cards, and also will do website design for you. Visit PrintPlusWeb.com to put your best foot forward. And now, on to the video. If you decide to order these kits for yourself and you want to have them shipped to North America, remember to ask to have the batteries removed. They cannot send the batteries over, but you can get CR2032s pretty locally without any issues. So these are Maximite computer kits. This is the Maximite Generation 1. It's the same one that David Murray reviewed quite a few years ago. Self-contained computer using the PIC32 microcontroller. Uses standard VGA, uses a standard PS2 keyboard, and an SD card reader. Now again, this is the Gen 1. There is a Generation 2 that uses the ARM Cortex processor. But we're going to go with these to start, just to see if I can get away with it. I believe they've done the surface mount assembly for us already. Yeah, these have been opened because I asked them to omit the batteries. There we go. Ooh. Okay. There's the manual. Oh, here's the board. Okay, they've assembled the PIC32 and one surface mount capacitor already. So that saves a lot of trouble. It means I won't have to attempt to do any surface mount. Well, with any luck, we'll get the regular components on here assembled and we'll have a functioning computer. And with any luck, we'll have 4 more. Well, here we go. All of the parts for this system are right here in the case. This case is supposedly a standard electronics case that is available at Australian markets. I don't know if they're available here. I'm hoping they are, because I would like to try to build one of these things from scratch someday. I have forgotten how to read these resistors, so I get out my multimeter and I read the values directly. After that, I can install them on here. This particular board has the resistor values silkscreened right on there. That is one big plus with the Ultronics version of the kit versus the original board design from Jeff Graham. With the component values in place, all I gotta do is get the right value, and then I can just put them in place here. Now, I haven't done a project like this in quite some time. In fact, I've never actually gotten a kit like this, ever. My understanding is that Ultronics is phasing out this kit, so if you want to build one of these things using their kit, now's the time to order them. They are blowing out the stock on this. You might want to order a few at a time though, because shipping from Western Australia is pretty pricey. But ordering 5 kits at a time, I was able to get a reasonable shipping rate. And by omitting the batteries, they were able to just use their own version of Priority Mail or Express Post to get this out to me. It got out here in about 2 weeks. And yes, this is a soldering episode, and please do not comment about my pronunciation of the word solder, okay? These are the resistors for the real-time clock kit. There we go. Just like David Murray, I did the lowest profile components first. In this case, it was the resistors followed by the sockets. And I tried to do this a little bit at a time where I would mount all of that values components at a time, and then I would if I remembered anyway, I would solder one leg of one group at a time to try to spread the heat around a little bit. Next came these signal diodes. These are part of the VGA output. I'm guessing this is to prevent feedback to the VIC32, the PIC32. Jeez, I've been doing Commodore stuff for too long. The chisel tip on this soldering iron was great for this. I was able to heat the component's leg and the pad. And there we go. And that did a very clean job. Next was this unique diode. I think this is part of the 9-volt input power supply to prevent feedback again. These had much thicker leads than the rest of the components. Next comes these, I think they're called Schottky diodes. I'm not sure what they're for, but they were just as difficult to install as that one diode by itself. Considering their location, they're probably part of the power as well. I missed one resistor, so we'll get that in there. My speed and my soldering technique improved as I assembled the remaining 4 kits. What you're seeing here is the first of 5 kits. Next comes the main crystal that drives the PIC32. The smaller crystal that drives the real-time clock was a little finicky. I had to grab a piece of resistor lead to wrap around that to hold the smaller crystal in place. I didn't actually read the instructions for this, but it made complete logical sense to do this for this particular crystal. Next came the socket for the real-time clock IC. 3 of the 5 kits didn't come with sockets. Eventually, I ended up skipping the sockets entirely. Next comes this surface-mounted SD card reader. There are guide holes on this board for the SD card reader to snap into to get the positioning exactly right. So I was able to get one lead down, and then make sure it was perfect in place, and then I got the other 4 outside leads down. Just like that. Next, I soldered the internal connectors. What I didn't realize that once the SD reader was in place, I could remove that, and there I actually removed it. And here I am cleaning up my poor soldering technique afterward, now that I could remove that insertion jig. And these are the leads for the write protect sensor. Please remember those, or your write protect notch won't work on the SD card reader. By the way, I installed these LEDs early, and I should not have done that. Not only did I install them backwards, I also installed them way too early. I'm supposed to save those for last, so they fit in the case correctly. Oh well. Now that all the low profile stuff is done, I do the slightly higher profile stuff. Those are the caps for the clock crystal circuit. These are the tantalum capacitors. That's part of the power regulation, but I installed them backwards. electrolytic caps, the longer lead is the negative lead, but on these tantalum ones it was positive. And this other cap here didn't have an orientation, but the battery holder wouldn't fit after I installed it, so on the next time I did this, I had to bend out the cap to make sure that the battery holder would fit. Next came these other caps that were part... What was at this end here? I don't remember what those were for. But next came these two other ceramic caps. Next came a much larger cap for the 5 to 3 volt voltage regulator. Next came all the little filter caps for the PIC32's input lines. This VGA connector was difficult to insert. I'm pretty sure that the guide holes for this didn't quite fit. The board was also missing plated through holes for the support points. Here I am, I'm trying to get the spacing right, back and forth, back and forth. I ended up stopping the recording just so that I could get past this part. And I'm still struggling with it. I don't understand it. Did they use the wrong template on this particular version of the board? Anyway, I finally got that to fit after a lot of effort. Next came the 9-volt input power connector. This board will take either a barrel jack DC connector like this one here, center positive, or it can draw power from the USB-B port that I'm installing next. I get one lead in there first, and then I give it a bit of a push to line it all up, and then I do the remaining leads. I use a big old blob of solder once the connector is flush with the board to make sure that these connectors are in place, because this holds some of the structural support of the connector, as well as providing electrical connections. Next comes the PS2 keyboard port, and this has a connector there with a plated through hole to hold things in place. Next comes the USB-B connector. This is one method of supplying power, and you can also use it to access the system from a PC. It also has big ol' supports points. This is a firmware programmer port. Do not press this button unless you have a PIC32 programmer. Next comes the battery holder for the real-time clock, which I realized only after the fact was not going to fit with that ceramic cap. I ended up cutting away bits of the battery holder to make it fit. There. Fortunately, the battery would fit still. Next comes the 5-volt regulator. This is for the 9-volt DC input to regulate it down to 5 volts. Next is the 5-volt to 3.3 volt regulator. The PIC32 runs at 3.3 volts, but the input-output pins are 5 volts, or they need to be able to support 5 volts. That's why there are 2 regulators. The 5-volt regulator has a big old heatsink on it. Next comes the power jumper. You can have a power switch on there if you want. I just stick a jumper on there. And I use a handy pin header here to hold the power connector pins in place. There we go. Now that's not going anywhere. And I can put a jumper in there for it to be permanent. Next comes the clock IC, and I built it far enough to test. So far, I've spent 90 minutes. So we'll try this one. Okay, here we go. Power. Oh, look at that! We do have something, but the LEDs are not lighting up. I might have them in backwards after all. That's disturbing because that means that other things are in there backwards too. Let's try a keyboard. Alright, so PS2 keyboard that I haven't even really tested yet. Oh, the monitor turned off. Okay, well let's wake it up. Battery back clock not set. It's accepting key input. Oh, the screen orientation's probably not right. Native. Oh boy, I have a problem. It seems to be overscanning or something. Okay, might not be such bad news after all. It was just my monitor. Right, I've got my cursor here. I've got my text. I wouldn't be able to do an auto adjust until I could throw up some kind of patterns. So let's see if I can get some software on here. All right, let's see if my hack job of this works. Oh, I don't know how to get files off of here. Let's go to the manual. My goodness, you'd think I'd remember how to do this. Let's see. Oh, it read it! Will it run? Look at that! No smoke. That's encouraging. There's my worry, is if I plugged in those LEDs backwards, I might have also plugged in the tantalum caps backwards. There we go. That's the classic Maximite color test. Alright, well, I'm gonna see if I can get these LEDs working, and after that, I'll solder the rest of the connectors. Yay, we got a working board! So, after fixing the LEDs and the tantalum caps, we try this again. The LED does work. That's encouraging now. But they're still in the wrong spot. I had to do some hacking to get those to fit in the case. But at least we do have a working system. Now that I know that it's working, I can begin fitting the Arduino Shields connectors. You can hook up Arduino compatible peripherals to this. You just have to control them a different way than you would with an Arduino. Next comes the programming header if you ever want to reflash the firmware on the PIC32. Next comes some programming jumpers and a general input-output connector, which will let you read things. These are general purpose analog or digital input-output pins. And you can use those to control anything from external servos, relays, lights, who knows. This is the audio connector. It does have a very basic audio system, but it's enough to be able to play mod tracker files. So let's power it up again. Let's make sure we didn't break anything. Oh, there's the power LED. I was able to get that fixed up. And here's the standard color test. Total build time was 2 hours, 30 minutes, but I got faster as I started building out the remaining systems.
So a couple of annoying things I found on this project. On 2 of the 5 kits, the VGA connector was missing these plated through holes for the VGA connector, which by itself isn't a big problem, except the ones that were missing the plated through holes. Also, the spacing was not quite right to fit the VGA connector. I had to struggle to fit it in there. That by itself wouldn't have been a big problem because the other parts of the kit went in, but then the other 3 of these had a bigger problem where the jig holes for the SD card reader were outright missing. Here are some boards that I got from PCBWay here, and these have the holes for the SD card's fitting points here, and here. These boards are a whole different story. It's a long story as to why I got these. Let's just say that I gave up on trying to program these PIC32s myself, and I got the kits from Ultronics, thinking, okay, at least I'll know I'll get these working. But yeah, you might end up with a kit that's missing the jig holes for this. It wasn't impossible to deal with, but if your skill set's not up to dealing with these surface mount parts, you might want to exchange them for the ones that have the guide holes. But then you've got their other problem where if you had the guide holes, the cap here for C4 wouldn't quite fit right with the CR2032 battery holder. I had to chip away either a piece of the battery holder or I had to bend up the cap so that it lay flat on the board for me to be able to fit these connectors together. So yeah, it's a bit of a mixed bag. There may be revisions of this board out there that have other unique problems. So good luck with those. In any case, I was able to overcome them and get 5 out of 5 kits working. I was able to fetch a library of basic files from Jeff Graham's site here. Oop. Yeah, let's insert that. Okay. It's just one of the demos that come with it. Now, a lot of people didn't actually cover this, but the PIC32 does have a little bit of internal storage, about 128K. It's on an internal drive A. Oh. And you can copy a few things there, like this mod tracker file. Hopefully the sound works. There we go. I think you're supposed to be able to play those while your basic programs are running at the same time. I haven't been able to get that going because if I try running this, it just stops the music, but who knows what's going on in here. Ooh. Uh-oh. I think this was meant for the Maximite 2. Let's see. Oh! Okay, we can use the keyboard. Oh, this is... Well, I wonder why they're not in color, but hey, who knows. Ah, of course. You'd think I'd know how to play Pac-Man. Oh, that's somewhat encouraging.
This other sprite demo didn't quite work for some reason. The full screen editor does work, but when I try to run this, it gives me a random error on these sprite copy commands. It might be a slight difference of the dialect of BASIC between the versions of the firmware, who knows.
So I'm going to cut this one short because I realized that I put together a kit from 2012. It is obsolete now, been replaced by the Colour Maximite 2. That's going to be a bigger challenge. But I figure, let's not put all this effort to waste. I'm going to see if this shows any interest in tomorrow's flea market, and if it does, then I've got some bigger plans. With any luck, some of you might be able to get one of these machines for no charge. Details will be coming once I iron it all out. Until then, good day.